In this video, we're going to discuss modern computer architecture. During the early days of the computer, to reprogram meant to require rewiring the circuitry of the machine. The von Neumann architecture, on the other hand, revolutionized computers for it treated both data and the program itself as strings of bits that can be stored in memory. In the previous video, we have established that computers perform only three basic functions: performing mathematical operations, storing data into memory, and making logical decisions in order to identify the path to take within the program. We have established in the previous videos that computers can indeed perform additions operation for two single-bit inputs and the carry. Stringing together these full adder circuits, in fact, can allow us to do additional operation for longer and longer strings of binary inputs. This is called the ripple carry adder circuit. The ripple carry adder circuit simply pushes and pushes the carry bit further and further in the string of full adders until the operation settles where there is no longer carry bit to push. In computer architecture, the components for mathematical and logic operations are combined together into a single packaged component called the arithmetic logic unit, or ALU. We have established in the previous videos that computers can indeed store data or instruction into memory. The von Neumann architecture employs registers within the CPU and RAM separate from the CPU. We have established in the previous videos that computers follow a sequence of instructions called programs. We have stated that the instructions that comprise a program are to be done step by step. The computer itself follows a certain beat, which allows it to keep track and follow along the instructions in a program. All the components of the von Neumann architecture follows this same beat. Therefore, the computer is never lost or out of synchronization. The beat is produced by a clock component, where the beat is an oscillating square wave that toggles between 1 or 0. This oscillating wave signals the computer when to start and end the execution of a certain instruction. More on the construction of the clock later in the course. Another major component of modern computer processors is the control unit, which directs the operation of each of the components. Memory, ALU, and input and output devices perform accordingly to carry out the program instruction. The control unit circuitry will be discussed later in the course. Aside from these data, memory, and address control signals must travel from it to each of the components of the computer system in order for it to function. These bridges between components are what we call the bus. Here is a diagram of von Neumann architecture. Thank you for listening.